Section 1.3, we're going to be looking at dot plots, analyzing them, looking at them, making them, learning all the characteristics in it. So section 1.3, here we go. You're going to learn how to make and interpret dot plots of quantitative data, right? Quantitative, not categorical, quantitative, right? Describe the shape of the distribution. We'll look at 3. Normal, skewed left, skewed right. We'll talk about what those are. Compare distributions of the quantitative data with dot plots. We're going to talk about how the data is distributed. Is it very tight? Is the variability low? Or is it spread like a tornado from county to county? Okay? Is it leaving a trail? Dispersed. Now, here we go. We've already, dot plots, you should have this down in your notes as far as the definition. And what a dot plot is nothing more than a number line and how many of those you have, right? We did a little bit of this the other day from transitioning from that to a frequency table, right? Kind of use it. But I want to show you something. See this right here? This is cool. That there looks like a dot plot, right? Is that what you see?
Yeah.
Is that all you see?
Yes.
Ooh. It's skewed left, it's skewed right, it's normal distribution. What is the data telling me?
Skewed right. So,
This is why I love the data. It's like National Treasure. Y'all watched the movie National Treasure? Okay, yes? If you haven't, go watch it. It's all in how you look at things. Knowing how to look at it tells you a story, right? Tells you the secrets, the next clue, and so forth, so on, right? Nicolas Cage, all the whole thing, right? Go watch it. That's stats. Amen. On the back of it. Yeah. Did you go with us to the 8th grade? Did y'all do the 8th grade trip? Y'all went, you wanted to do the 8th grade trip. Y'all did see it.
Yeah,
Really?
yeah, we did.
Did you remember seeing the palm print down at the bottom of the Declaration of Independence?
Yeah,
The palms? Y'all remember seeing that?
yeah.
Yes, they are.
Whose palm is it?
What?
Whose palm is it?
I don't know. Probably one of the signers from Georgia, because the Georgia signer signed on the left-hand side. Who were those signers? Anybody? George Walton, Bud Gwinnett, and Lyman Hall. All 3 counties are right there close together. Now,
Oh, girl.
look at that map, teacher come out with some history. Woo! That's going on. Look at that right there. Now, that is not normal distribution. This is what a normal distribution looks like. Like that. It's a 1-hump camel, right? If you stand up here on top, right there, look left, right, it ain't no advantage. It's the same slope both sides, right? So we're going to talk about this. Right? And then we're going to talk about, yeah, we can talk about that, aren't we? That went off the page. We're going to talk about that, right? Okay. Now, how can you tell what's what? This is normal, right? There's other words you could call it, but normal distributed. This is, I think of it like this. So I'm gonna draw this little guy up here. And I'm gonna put on some skis. And there's his. So this guy's skiing. So I want you to think about, how is he skiing? Which way?
down
To the what?
The right.
the right.
To the right. So you put the guy up on top of this mountain, you see how he's skiing. He's skiing to the right. That's skewed what?
Right.
That's skewed right. What's this one?
Left.
There you go. Okay, so that's what I'm talking about. If you know what you're looking at and everything, you can see a lot of stuff. This data is skewed to the right, which means majority of your data is where?
Left.
Right here, and then it's scattered like a tornado this way, right? Like debris, right? And we might have considered points way out here as what? Outliers, man. Y'all sure y'all haven't had disgrace before? Y'all smart. You're smart, pay attention. All right, good. I like that right there. Now, any question on this? So if they say skew left, skew right, what are you gonna think of? A ski mask? Put the man up on the hill. Which way's he going?
Down. To the right.
Lord help me. Woo, we just prayed. Yeah. Which way's gonna be the funnest ski? This way's to the what?
Right.
Oh my gosh. We're not doing extreme sports, okay?
To the right.
No. What's gonna be the most enjoyable, longest trip?
To the right.
To the right. Thank you. Skew right. Thank you. Hey, yeah, y'all just like short trip, boom, done. No, we don't do that. All right, how to make a dot plot. It's not hard to make a dot plot. It's number line, put the numbers underneath it, put the little dots represent frequency or the number of, right? Looking at that can tell you how your data is distributed. It's a really simple tool that really has a lot of value without having to do a lot of computations. It's a quick and dirty. I hate quick and dirty. It's a quick way to analyze something. It's a tool. Now, is it the best tool to really dive in and see a bunch of stuff? Yes and no. It gives you some bit of the story, but it doesn't tell you the whole story like that. So it's a snapshot. What is it tell you? Okay. Scale and axis, blah, blah, blah. Tick marks, right? Plots of the values. Try to make them dots the same size, right? That's key. Uniform. And label your axes, right? Okay, so this is what we're talking about, right? They called it symmetric. I called it what? Normal, right? I may be wrong in this, but I think another term would be unimodal, right? One mode. So there's different vocabulary that you can associate with stuff, and there's different ones of these that will kind of pull underneath the umbrella and use. But right now we're doing, I call normal, they say roughly schematic, symmetric, skew left, skew right. Fair enough? So you need to kind of understand what those look like. So what I need for you to do is just kind of draw that and label what they are underneath. You get to draw your skew left, skew right, and a symmetric or a normal distribution. So please take this time to do that, because you will refer back to it. And when you get done with that, we'll talk about this. Okay. Go ahead and, when you get done with that, go ahead and, let's see. You need to know how to describe the distribution. You need to know about shape, its center, and variability. So I would answer that question with these three words. So you need to get that down as well. All right. So in a distribution of a quantitative variable numbers, you can have a shape. We talked about that, right? Skew left, skew right, normal, or symmetric. Center. Now, center could be two things. The center could be the median, which would be the middle of your data set, or the center could be the mean, the average, right? Okay, so when you're talking about center, you got to make sure which center you're talking about. Fair enough? So right now, it just says center. So we'll investigate what it is. Variability. Variability is how spread your data is, or how tight your data is, right? Okay. The smaller the variability, the more statistically significant the data is going to be. The more you can make reliable predictions on this stuff. Okay? If it's spread, like tornado spread, you can't make a prediction. It'll be a, basically a statistical significance value right around 0 or close to 0. Okay, you can have negative or positive significance. Now, for this one, we also got to consider things such as outliers. And if you look at this, you can see that this right here is what? Skewed which way? To the right. You see this little data point right here?
Yeah.
What is that? Outlier. Now, an outlier is 1.4 or 1.5 times the mean. Is it 1.5? So that's how you can calculate to see if you have an outlier. Okay? And we will. But do you see how you can do this? Do you know? Well, I can't tell you that. That would lead into something. If we're looking at age in here, I'm an outlier. Why?
Because of the big gap.
Big gap between who?
Us and
Yeah, it could be 16, 17, 18 years old here, right? One of those three is, I could very safely say you'd fall in those categories. 16, 17, 18. I'm 47. I'm way out here. I'm almost 3 times you. Right? So I would be that one. Now, let's look at this. Comparing distributions of quantitative data in a dot plot. We have the UK, the number in a household in the UK is up top in green, and the number in a household, no, sorry, the top is South Africa in green, and then UK is the purple, the bottom. So the number of people in a household. So let's kind of look at this. Let's look at the bottom, the purple one. What kind of distribution do you see here? What kind of spread does it have?
Narrow.
It is, for the sake of basic purposes, it's pretty what? Normal, symmetric, right? Pretty, it's, everything's tight. The variability, everything is really what? Really tight, right? Over here, look at this. It's skewed what? Right. So we know we have some like data all grouped in, and then we have some that are spread out, right? So how do we explain the spread out? Okay, the number of people by household. So that's UK, right? United Kingdom, which includes what? Wales, Scotland, it's all a bunch of countries, right? When we say South Africa, are we talking about one place?
Yes.
Are we talking about one place? Or are we talking about a region of Africa? I would say a region. Why would I say a region in this case? Because the first one is what? United Kingdom, right? Which takes into account several. That's how I would interpret. I wouldn't say South Africa. I'd say all the countries in South Africa, right? Does that make sense? Congo, all that stuff, right? In that South Africa, yeah.
Isn't there a South Africa country? Like in the bottom of South Africa? Like
Yeah.
there's, isn't there?
Depends on
I would defer to my geography gurus.
There is.
Yes, there is.
Survey says yes. I don't know. I haven't looked. I don't know. Yeah. So, most of the majority of the households in the UK, the average number of people in the household are right around what? 4 to 5, somewhere around in there, right? Now that means mom and dad and 2 kids, right? Mom and dad and 3 kids, right? That's normally what you get, correct? Does that seem odd to what we have today here in the United States? No. Okay. Let's look at South Africa. They have lot, or I should say lot. You have small, I say small, 4 to everything's group 10 or up to 10, and then it also goes and increases more. Why? Why do you think the South African data is different from the UK?
Not a first world country.
It's a what?
It's not a first world country.
So it's, I hate to say it's a third world country.
It's like developing.
It is a developing nation. UK is more of a developed nation. So that's a good way to put that. it's more developed in some areas than others, right? We think of South Africa, I'm thinking, safari, rural areas, right? I could be completely wrong, right? I don't know, I've never been. My perception of out west was changed when I went, guess where?
Scotland.
Out west. Surfing? Did you say surfing?
No, it says South Africa.
No, I didn't go. I haven't been, but your perception of things changes as you go and experience them. You have a preconceived notion of what things are. But I want to ask you this. Does it surprise you that the amount of house members per household is bigger in South Africa as compared to UK?
No.
No, why? Why do you think would be a contributing factor? Let's tell the story, or at least a little bit of the story.
There's less housing available in South Africa.
Could be how the family unit is arranged,
Is there like more farms?
farms. What about farms?
They
A lot
have
of
kids
kids.
that work on farms.
That's called free labor. It is. If you grow up in a rural area, you either have to pay somebody to work it, right? You have to get labor to work it, or you get what's called free labor, which is kids. Mom's one of 14, dad's one of 12. Mom's one of 14, they had 14 kids. They were sharecroppers. They worked in the fields. They moved from fields to fields, this, that, and the other, picking crop. So that was free labor, right? You didn't have to spend that expense on paying outside help. You got paid to come sit down at the table with clothes on your back, food on your table, and a roof over your head, right? That was how that, so that's why. But it changes based off the environment that you be in, okay? Right now in the United States, if we're looking at the United States, families are small. Not too many families greater than 4 to 5, maybe 6, right? Why?
There's no need.
Huh?
There's no need.
The need, that's right. So there was a need that's probably being met here. And it's probably more than a need than what we've said, right? So there's a lot of different factors that play into that. So when you just look at something, don't just go, oh, that's skewed right. Yeah, it's got an outlier. Think about what contributes to that. Find the story that's behind the data, right? Now, I'm doing this kind of, I hate saying impromptu, but I'm doing it ahead of the game because as we move further into this course, those skills I'm doing on this stuff are going to be there. So there's a reason for what we're doing. Fair enough? Good. All right, so here we are. This is you doing practice, right? Correct? So how can we check the health of a stream? Nitrates or organic compounds are the main ingredients for fertilizers, right? When those fertilizers run into streams, the nitrates can have toxic effect on fish. Ecologists studying the nitrate population in 2 streams measure nitrate concentrations at 42 places on Stony Brook and 42 places on Mill Brook. The parallel dot plots display the data. They get 42 readings, right? So, what can you tell about Stony Brook compared to Mill Brook?
It's skewed to the right.
Huh? Is it skewed to the right?
The first one
It's
is
more uniform.
real, but has outline.
What do you think?
The first one's skewed to the right.
You think the first one's skewed to the right? Why? Because you can ski?
Yeah,
Then you got a little jump hill, right? Woohoo! Right? Like maybe like this, right? Would that be bimodal? Could be. Depends on, does it fit in that category? What about this one? Can you do any description of the distribution here?
It's a little more uniform.
Is it?
Could it be skewed?
What about the variability? Who has the tighter variability?
Stony Brook,
Stony Brook. Why?
because they
Or
don't have
because there's
that.
less rain.
Okay, good. What about Millbrook? It's more spread out, right? The data's more, it's not clumped up together, correct? So, explain what the dot above 12 in the Stony Brook graph represents. The dot above 12 in the Stony Brook. Here's 12, right? So we'll go straight up, right? What does that right here represent? What is it trying to tell you? Yeah. Yeah, that's exactly right. There's 12 milligrams per liter of nitrate concentration in Stony Brook. There you go. It's a data point, right? Now, you can say, well, is it the max? No, it's not the max, right? What percent of nitrate concentration measurements for each stream exceeded 10 milligrams per unit? We're about to go. No, we got 1255. We got 5. Yeah, we're good. What percent of nitrate concentration measurements for each stream exceeds 10 milligrams per unit? Ooh. So what do you got to make? Huh? You can make a table, a relative frequency table, right? But how many data points do you have? How many do you have? 42. That exceed 10. So is 10 in it?
Yes.
If it says exceeds 10, is 10 included? Yes or no?
Yes.
Okay, oh, let's take a vote. How many of you think 10's included? Raise your hand. Raise your hand if you think 10. Don't be shy. It's okay.
I don't know.
Okay, take a stab, take a chance.
I'm going.
10 is included. Raise your hand. Okay, all right, come down. 10 is not included. Okay, raise your hand if you like. I don't know.
Well, I don't know.
Okay, if something exceeds something, is that value there?
No. Yeah. Well, no, I said no.
If you're going faster than 55, is 55 there?
No.
No. That makes sense.
Now you know? There you go. So,
I-
10 and above, right?
You were.
So, what do you gotta do? You gotta count the dots that are what? Ah, above 10,
So start on the left.
right? So that's what you need to do to number 2. So you need to do that, right? So answer that, you figure that out. And then compare the centers of the two distributions, right? Where you think the center is. And then is the variability in the nitrate concentration for the two streams similar or different? Justify your answer. We've answered number 4, have we not?
Wait, what?
Yes, there's 2 pages to this. There's 4.
I know that, but I don't know.
Okay, you with me? All right.
I mean,
So we've answered number 4 already. We've talked about it, right? So you should be okay. Compare the centers. So I want you to take a stab on what you mean by centers. And we talked about it could be what? The median, or it could be what? The mean. That when you talk about centers, you could talk about those two. The middle of the data point or the middle of all the numbers. Right? So that's what I want you to do. You need to answer all those. There's just you got to do this one, number 2, answer number 3, and then number 4 we talked about, right? So I need you to do that. Okie dokie? Okay.
Did you explain how to do number 2?
Did I explain how to do number 2? Yeah. Count the number of dots above 10 for this one. So that would be that over 42, right? Count the number of dots above 10 on this one. that'd be that number before two, right? Right, what percent, correct? Part over whole, percent's a fraction, right?
So do it for the,
Yes, you gotta do it for both Stony Brook and who?
Millbrook.
No,
Right, it says for each stream, right? You with me? Yeah? Aaron, you got stuff, you got your packet?
Are you gonna go over?
Not
today?
nothing.
No, because we're about to go here in a second, in about less than 2 minutes. So, but we got to that, that's something we can pick up and hit on Thursday, and then right on into 1-4 and 1. Guess what? Okay? Your homework is on Canvas for 1, 2, and 1 what? 3. Yeah, they're there. Okay?